Oh, okay.
What's that, Luna?
The grass.
Yeah?
Oh, it's supposed to be for Friday.
Yeah, the graph is not today.
Yeah, that's right. Yeah.
Who's on saying?
Muna, do you mind handing me the worksheet? So what do you want to see from the tangent line one? 2.
2 X, please. Yeah. So you told us to do one from each?
Yes.
So 2 is confusing. It wasn't.
No, the homework was to do one from each.
No, I mean from this one.
That's for
That's
Friday.
everything for Friday. But then I'm pretty
Even
sure
one
next Friday is
for-
one for
Everything on that page is for Friday. Okay, so let me think. What do you want to see from this tangent line one? 2x. Yes, that's it.
Again.
Okay, 2.
It's the same. I'm confused between 2 and 3. It's exactly the same.
It's nearly the same except 3. Basically, in number 2, you don't have to find the c, whereas in number 3, you have to find the m and the c.
Number 2, the C is, okay, and X is 9, right?
Yeah, I'll do it. Just watch. It's okay. Right, 2x. Okay, so we have what? Oh, sorry. There we go. So we have y equals 4x squared plus 4x plus 9. Uh-oh. I was just trying to get rid of it. There we go. Okay, and it's at the point 1, 0. Oh, sorry, no, it's not. It's at the point
minus 1.
-1.
4X squared.
And there's a square here. There we go. Okay, so firstly, if I just roughly sketch this is the situation. We have a quadratic, we have a tangent line, and the point at which they meet is x equal -1. Got that? Now, what's the equation of this tangent line? Well, like any line, y equals mx plus c. And what is special about this meeting point? It will be the solution to these two equations. And what technique is best used to solve them? The substitution technique. So you get 4x squared plus 4x plus 9 equals mx plus c. Now, you know two pieces, well, let me simplify this a bit. So you get 4x squared plus 4 minus mx plus 9 minus c equals 0. There's two things you know. You know that this should be true when x equals -1, and you also know that it should have one solution. If I put in x equals -1, that's okay, but I mean, it's not going to give me the answer just yet. So if I put in x equals -1, I get 4. -1 times this would be plus 4 minus m, because the -1 flips them around. Plus 9 minus c equals 0. So therefore, m minus c equals -9. So that does not give me the m, it does not give me the c. I just know that together m minus c should be -9. But I now can use the fact that this has only one solution. So its discriminant should be 0. So b squared minus 4a times c should equal 0. Now, watch. Well, I'll pause there for a moment. Are you happy with how I got that last line there? Discriminant equals 0. The delta equals 0. Now watch this trick. But 9 minus c equals -m. Now, why on earth would I do that? Well, I don't have to, but I've just spotted a shortcut I can take. Because I can put 9 minus c to minus m, and then what will be left? A quadratic of m. And what am I looking for? M. So if I put that in there, I now get 4 minus m squared plus 16m equals 0. So I will get m squared minus 8m plus 16 minus 16m equals 0. So I will get m squared minus 22m plus 16 equals 0. Yeah, something feels wrong. What's the solutions to this? For sure? No. The answer to this, not the answer at the back. Mode 53, Samira, please. Right. I spotted the mistake. For some reason, I changed my plus to a minus here. That's wrong. That's a plus. So it should be 16m minus 8m. So that should be an 8, not a 22. All right, now it looks much better. So m is 4 here.
Isn't it plus 8m?
Sorry, minus 4. What's wrong?
Isn't it plus 8m plus 16?
Plus em plus what?
8 your...
Oh. Yes. Thank you. Minus 4, which is the answer at the back.
What's the difference between this question and question 3?
Hang on, oh man, I am so tired. You make me tired. Is this wrong here? My trick here. 9 minus c equals, oh no, that's right. 9 minus c equals, yeah, sorry, this is right. Just double checking. Took that to the left and took the m to the right. Yeah, that's fine. Sorry, what were you asking me, Muna?
I was asking, what's the difference between this question and question 3?
Oh yeah, so that's 2x. So how does this differ if it was 3x, for example? So this extra part now would be the difference. I'll do it in blue, okay? What you would do next is you'd say blue, yes, there we go. Y equals mx plus c. Y equals minus 4x plus c. So to finish it, Muna, you just need to find the c for the line. How do you find the c? How do you find the c? No? Substitute what? What point? Use, yeah, x. But what's the y?
9.
No? How do you find it?
You substitute.
Yeah. If you look at the question, I give you x, do I not? But I don't give you y. But I really do, because you can just put the minus 1 into the formula to get the y, which would be 4 minus, which would be 9. So I won't do it, Muna, but to finish, you'd use that point in there to find the c, and that's the only addition.
No, that in blue, that's not.
Samira, I'm not stupid or blind. Yeah, like the tables don't have any cover in front of them, so I can see when people are using their phone. So you might as well use it right in front of my face when you do it under the table. All right? Don't insult me like this, please.
The blue is not from the answer. It's
Yeah, the blue is the difference between 2 and 3. So in number 3, you would have this extra piece at the end. Alright. Can I have a look at see what the next topic is? This, it will be...
because I never opened it.
First principles.
Oh yeah.
I thought check something. I was worried all of a sudden I didn't spell principles right, I did. Because you know in English there's two ways to spell it, right?
Yeah.
Yes. No, I don't, that's okay. No, it's, sorry, if you didn't notice, this principal means two things. The name of the person who is running the school.
A.
Huh? That's the one with the A, yeah. And then the other one, which is the idea, which is what the one we're doing. Okay, so scrolling down now, we're going to look at the next lesson. Yep. Okay, so here's the problem. We have our curve. This is given to us. So this could be y equals fx. So for example, what type of curve is this one here? Quadratic maybe? No, that's not what I was asking for, NB, and you know it. What type of curve is this? It's not 2x. X squared.
I said 2x squared plus 3x.
Oh, so I missed all that extra part, I'm sorry. So this one here, maybe like a quadratic, okay? So that's given. Then also what will be given would be, say, this point here. Let's say x, we'll just call it x or x0 or whatever. x0 maybe. So that is given, and what we would like to find today is a precise way to calculate the slope of the tangent line. So how can this be done? Well, if you think about it for a moment, this is a tangent line, and if I draw this line here in blue, that goes through x0, bluish. Is this blue line a tangent? It is not. What is it called? The secant. But the slope of it is roughly the same as the red line. So what I'll do to start is I'll say the slope of the blue line of the tangent is approximately equal to the slope of the secant. Now if this point is x0, how would you find the y? How do you find the y? Like I did in the last example for you? If I give you the x but I don't give you the y, how do you find the y? Sub it in. So the y here would be f x0. Okay? Yes? MB?
Yeah.
Are you listening?
Yes,
Are you sure?
No,
Alright, okay.
I write them while you're writing, so it becomes easy.
No, it's just surprising to see you working, that's all.
I'm not working, I'm writing.
Oh, they're two different things, I'm sorry, of course, yeah. Right, so that's x and fx0, and then this point here, I'll call it x0 plus h, fx0 plus h. And the h is just the, if I get a different colour now, let's go with this kind of gold colour. The h is the horizontal distance between them. So if we think back to like lesson number 2 maybe, or lesson number 3, if I give you 2 points, it's not difficult to calculate the slope. How do you calculate the slope? Do you remember the formula? Oh, this thing.
Yeah.
Yeah. So, y2, whoa, that's wrong location. y2 minus y1 over x2 minus x1. Now you can simplify this a little bit. What happens in the denominator? Well, in the denominator, you'd get just h. And in the numerator, you'd get the same thing. So, approximately. Now, maybe introduce some notation. Do I want to do that yet? Let me think what I'd like to do. Okay. Slight side note for the moment. So that's why I'm literally going to the side.
It's one question.
Yes.
Is that x? Like
X0. Yeah, subscript 0. Side note, just so you know, so you don't get confused if you see it, the top is often called delta y and the bottom is often called delta x. The reason for this is because delta means change. So fx0 plus h minus fx0, that is like the change of the height, which we call delta y, and delta x we call the change in the horizontal. But that's just a side note not to worry with at the moment. So you can just write that as delta y over delta x. But back to the main show here. Now, remember we said that this is an approximation. How could we improve the approximation? So for example, if the points are closer together or further apart, which of the two would be a better approximation? Closer together. Because if you go back to the graph, if this, where's my cursor gone? There it is. If this point was closer here, like imagine right here, if I draw this secant between these 2 points, oh, sorry. You see how the black line is of a closer slope to the blue line? And what would happen if the 2 points became so close together they became 1 point? Then it'd be a tangent then, because there'd be only 1 point instead of 2. So in fact, what you can say now is the slope of the tangent is equal to this, fx plus h minus fx all over h, where you make h, we say its limit, h goes to 0. So the best way is with an example here. I also would like to point out that some people prefer to write the formula like this, which is totally the same.
What's limit? Is that
Limit just means like we did in sequence and series. But here we can just take it to mean you make h go to 0. In other words, it's like h equals 0. Some people write the formula like this, which of course is the same thing. I mean, I've just changed the letter, that's all. So these are called first principle formula for slope of a tangent. I'm pretending like you don't know this word because I'm trying not to use it. Or another way to call this is first principle differentiation. Arabic students, that is first principle mushtaka. Something. Yes. You know this word? Yes. I'm pretending as if we don't know this word because it's like I'm imagining this is the first time you're seeing it. Well, I don't know. How many people have seen this formula before? You've seen it? Well, that with me, is it? Or you saw it before here? And you remember this formula? Yep. Anyone else?
I don't know what this is, but I know how to differentiate.
Yeah, but Oh man. But in the exam they could ask you to use this method to differentiate. Yep. Have you seen this formula before?
Just the limit thing.
You've seen lim before, yeah? Okay. I want to use an example we just did to really demonstrate this formula. So if we go back earlier, we got slope is -4. So can somebody, I just need you to read this, I need you to read this quadratic out to me that you wrote down earlier, 2x. So we'll look at an example now. Okay, so in 2x, where's my cursor? Oh,
Just a question.
oh there it is. Yeah,
There's also the limits.
yeah. What are you asking me? Yeah,
I said something also with the limits.
yeah.
It's the same thing. No, not to apply the slope to tangent.
Yeah, we've seen limits before in sequence and series.
Other than that,
Other than that,
yeah, it's with sine, cosine.
ah,
I forgot.
you might have.
It's hard. It's really hard.
Yes, and in fact, I think that might come up in the Derive exam. Remember, we have to do that in Derive anyways. Okay. What was I saying? Oh yeah, give me the function please. What's the quadratic? 4x squared,
Plus 4x plus 9.
and the x is
Minus 1.
-1, or if you prefer the x 0. This is just my own example, but I'm using one that you had for homework. But I'm showing you this technique to calculate the slope of the tangent. So I'll repeat that again. The way you would describe the technique that you did for homework, you might call by using the discriminant. The disadvantage with that technique is it only works with quadratics, but that's okay because we're only using quadratics at the moment. This technique is much better because it can work for anything. So I'll use a quadratic because we know what the answer should be. It should be -4. Yep, right. So first thing we do is we calculate this, f(x plus delta x). Meaning we replace x with x plus delta x. Expanding. And then that. And then that one. And that one. Plus 9. Cleaning up. I would like to group, there's the x squareds. Sorry, let me think. Let me just get rid of this. How do I want to group it together? Yeah, the usual thing is we write the delta x's first and the non-delta x's second. So how many delta x's do I have? I have 8x delta x, oh, plus that one there.
You have
So
to-
8x delta x, 4 whoa, uh-oh. 8, 4, anywhere else?
4.
Well, this is a square, but that's okay. I'll just put a different symbol under it. So 4 delta x squared plus 12 delta x plus 4x squared plus 4x plus 9. That's the 12x delta x. That's 8x delta x. Oh, no, they're different. Thank you. Rewind, and restart. 4 delta x squared plus 8x delta x plus 4 delta x plus 4x squared plus 4x plus 9. I haven't actually done anything there except put the delta x's first, non-delta x next. Don't worry, I'll scroll back to the right, but I'm just going to flick to the left here. Next, I'd want to calculate this. Now, we know this, yes? And do we know this one? Yeah. So, it's just going to equal that exact same thing, except what do I put at the end? Exactly the same, except now minus f of x. And what's f of x? Minus 4x, is it 4x squared? Minus 4x minus 9. Now you can see the reason I put the x piece at the back, because what happens now at the back? This cancels this, the 4x cancels the minus 4x, and then the 9 cancels the 9. So that's why I scroll to my left now, because everything at the end is gone now. Yep.
Could you a little bit zoom out?
Zoom out. I don't even know if that's possible. You know, I'm just looking for a zoom button. Ah.
Thank you.
Can you still see that though?
Sort of.
Yeah.
I mean, much better.
There we go. Right, you Shaban.
I'm done.
You're done. All right, come on.
Yeah. You're asking me many questions to help him.
That's okay.
Yeah.
All right. The formula is fx plus delta x minus fx over, well, if I'm using delta x here, over delta x. So what would I have to do now? Divide by delta x. So delta x squared divided by delta x, just delta x. Delta x divided delta x is gone. Delta x divide delta x is gone. So I'm left with 4 delta x plus 8x plus 4. Now, not finished yet, because what do I need to do with my delta x to change it from secant to tangent? How do I change a secant to a tangent using this formula?
Yeah.
No? You just came in, you have no idea what I'm talking about. No, not this. Secant to tangent. What do I do? No, come on. What's special about the delta x when it goes from secant to tangent?
It's equal to 0.
Yes, remember? You make delta x go to 0 to change from a secant to a tangent by changing the 2 points to 1. So now, making the delta x go to 0, what am I left with? No, there's no surprises here. What am I left with?
8x plus 4.
8x plus 4. Now, I give you the x in the question. What did I say the x was? So now it's at x equals minus 1. So what's the m? Minus 8 plus 4, which equals minus 4. Does that answer look familiar? Well, yes, because it is the same answer. But immediately you can see an advantage with this technique, because now if I said, okay, this time give me the slope of the tangent, but when x is 5, all you have to do is what? Change at the end that x to a 5 instead of a minus 1. So what's nice is that in some way we've produced what you might call a general formula for this quadratic. You give me the x, and I can tell you the slope of the tangent. So for example, if x was equal to 10, what would be the slope of the tangent for this quadratic when x is 10? What would it be? 84. Now I think to really, again, appreciate this, we'll need to look at the graph. So what I'm going to do is I'm going to draw the graph, and I think we can draw the tangent line as well, and we can see how the slope changes, okay? So to start with, if I put x as 0, what's the slope of the tangent line when x is 0? 4. And then when x is 1, what's the slope of the tangent? 8 plus 4, so then 12. So as x moves to the right, what's happening to the tangent line? It's getting steeper. Yeah. So can you read out the quadratic to me, please? What is it? Y equals, come on, 4 plus 9. Okay. Now I don't know, I can't remember the command. Let me check. Let me just edit this actually to get rid of the y. Okay, tangent. No. Eek. Okay. Right, so firstly let me draw that. Right, where is it? Do I have to zoom out? Uh-oh. Oh, there it is. Sorry, it's a bit... Whoop. Alright. So when x is 0, what's the slope of the tangent, did we say? 4. So let me draw the tangent line on the graph at 4. There you go. So you can see it's 4. Now, when I put x as 1, would the tangent slope increase or decrease? Increase. What should it be? If x is 1, what's the slope? 12. So let me step along here to x is 1. And can you see that in green? Oh, it's a bit faint. That's the next one here. Now if I step along, let me step backwards. So if I go to minus 1, what can we say about the slope of the tangent? It's going down, so what should it be? Should be negative. Well, in fact, we know the answer. When x is minus 1, what's the slope of the tangent? Minus 4. And then we draw it in. Whoop. There we go. So you see here, here's minus 1. The slope is minus 4. Here is 1. What was the slope? I think it was 12. And then at 0, there it is there, the black line. I think we said the slope is 4, wasn't it? Now, let me just get rid of all this for the moment. Now, at what value of x will the slope of the tangent be 0? No, what value of x, the number? So just in your head, hey, you all have imagination. What can I make x be to make this 0? Minus a half. Right? Yes? Right, good. So let me draw this again. Alright. And now, what was the command? Y equals tangent of 1x minus 0.5. So if the slope of the tangent is 0, what type of line is that? Okay, are you ready for this? Yeah, there you go. Yeah. Mind blown. And in fact, finding this is something we did in semester 1, the earlier part of semester 1. What was the technique we used to find this point here. Because what you notice is the slope of the tangent is 0 at the lowest point of the graph, which is called the vertex, or the minimum. And what technique did we use to find the minimum? Completing the square. And if you use complete the square, you would find that x would equal minus a half. Also. So I am trying to tie in everything together. Yeah. Some of you will appreciate this, some of you will not. Okay, so most important is this part here. But I wanted to show you the graph because I think it is nice to see what exactly is happening as you're doing these calculations. So once you have finished writing that down, I'll tell you which ones to try for Friday.
Day, it's a big day.
Yeah,